I sure am thankful for this easy and simple method of finding out the volume of something.
But wait! What if I told you there was a way, and now hear me out, of using math to solve for the volume of that pencil?
But I am going to use math. I subtract the initial volume of the water from that volume after adding the pencil.
No. I'm talking about calculus. Picture this. Let's find a few values, integrate, and see where we end up.
Integration who? Never heard of her.
I'm not going to explain it again. I made a video on that last semester.
I'm still not sure. That sounds a whole lot more complicated than it needs to be. ...
I'm telling you, I think you'll really enjoy this. So first I'll start by graphing 1/2 of the cross-section of the pencil, which we measured out to be approximately 22 centimeters long with a radius of about 1/2 centimeter. The slope of the tip of the pencil seemed to be around 3x. The method I'll be using requires that we rotate this cross-section around an axis, so we'll mark this on the graph with this circular arrow. In this case, we're rotating it around the y-axis. The formula I'll be using is going to be pi times the integral from a to b of the function squared dx. In our case, on this particular graph, we'll need to integrate the tip of the pencil and the cylinder part separately. Beginning with the conical end, we're going to place this disc perpendicular to the axis of rotation and establish our new bounds as being between 0 and 3/2. Then, we're just going to plug the numbers into our formula, simplify, and integrate using the power rule of integration. Because we're working with a finite integral, we now need to plug in our bounds in order to get the real volume of the tip of the pencil. And it looks like for this part, our volume is pi over 8 centimeters cubed. Next, we're just going to repeat the same process but with the main cylinder part of the pencil. The volume then would be 41 pi over 3 centimeters cubed. Now, because we integrated this pencil in two pieces, we need to add our two values together to get the full volume, which comes out to be 42 pi over 8, or approximately 16.493 centimeters cubed. So, I told you it would be a literal blast.
I still think it would have been faster if we had used the water and beaker method. Yeah, there we go.
Faster, maybe. But would it have been nearly as much fun? I think not. We have to use our heads.
Our heads!
Our heads! Okay, cool. And then now, just cut to this. Grab one, and me too. Okay, anyways, get over here, we're filming. It's just gonna be a zoom in of, no, of you, the pencil in the water. And then it's like a zoom in and we pull the pencil out. Okay, hang on. 1, 2, 3, go. Oh no.
Anna.
Anna. Ah! He's sad. Rip. Literally. Action. I said it after I started recording. Okay, anyways. 1, 2, 3, go.
Man.
Yeah. Okay, let's go. Oh! No! So, I told you that'd be a lot of fun.
I still think it would have been faster if we had just used the water and beaker method.
Faster maybe, but would it have been nearly... Oh, I messed up the first line. Let's reset. Woo! Woo! I think it's not resetting if I don't have the script in my hand, so that's good.
Okay.
If I hold it like this.
Sure.
Like this.
A painting?
You're not wearing your goggles!
Oh my god.
Lab safety!
Thanks for being lenient, Professor Graham. You're great. I gotta zoom out so you can get my thumb. I got a marker in it. Pretty girl.
I know, I'm sorry. I didn't think about it until now. And I feel bad that I like roped you in just to hold the camera. So maybe we can, if you want to be in it, we can invite you in. What do you think? You seem cute? Oh, hi, pretty girl. Ah, no.
Okay, I'm putting this down so I can pet her.